Hello there. Have you ever gazed up at the night sky, at that familiar, solitary moon, and let your imagination wander to a truly wild, what if? What if our moon were to split in half? It's a thought that might conjure images of cosmic chaos, but what if I told you it could lead to something unexpectedly beautiful? Imagine this, instead of an end, we're treated to a breathtaking celestial ballet, two smaller moons, like luminous pearls, dancing across the darkness. But what would this mean for our world? How would the tides behave? What would an eclipse look like with this new configuration? And what incredible cosmic event would have to unfold for Earth to be adorned with rings, much like Saturn's majestic display? This is a journey into a fascinating hypothetical, and it's a good one. Let's set the stage for our scenario. We're assuming our moon is perfectly cleaved, with half its mass in each fragment. Now, how much energy do you think that would require? Forget a few fireworks. We're talking about an astronomical amount. The Tsar Bomba, the most powerful nuclear weapon ever detonated, is equivalent to 50 million tons of TNT. To split the moon in half would demand the energy of roughly 30 billion Tsar Bombas. Now, if we just cut it and left the halves close, they'd simply snap back together. Not very exciting. So, let's imagine we pull those halves apart, creating a separation of 10,000 kilometers. And to make things visually stunning, let's envision these halves reforming into two perfect spheres, rather than awkward crescent shapes. While gravity would naturally round them over millennia, we can imagine that process happening much faster for our thought experiment. So, what happens next? As these two new moons begin their journey, they'd naturally be drawn towards each other. However, with one ever so slightly closer to Earth, our planet's gravitational pull would be just strong enough to prevent a collision. Instead, they'd settle into a stable orbit around each other, with Earth at the center. Initially, their orbits might be a bit elliptical, but within the first month, they'd find a harmonious rhythm. Completing an orbit around each other in about 25 hours, their movement would appear quite gradual from our perspective. But over the course of a night, the visual would be truly captivating. One of the first questions that comes to mind is about eclipses. We're incredibly fortunate on Earth. The sun and moon appear to be almost the same size in our sky, allowing for those awe-inspiring total solar eclipses. Most other planets don't get to witness such perfect alignments. Now, imagine an eclipse with our two new moons, each about 20% smaller than our current moon. The view would be different. With their smaller size, more of the sun would remain visible, and because they orbit each other every 25 hours, we'd witness a new kind of eclipse, our twin moons chasing each other across the face of the sun. These would be incredibly rare, but can you imagine the spectacle? During these mini eclipses, roughly 40% of the sun would still be visible, meaning the dip in brightness would be about 500 times less intense than a total solar eclipse. And while temperatures might normally drop by about 5 degrees Celsius, with our smaller moons, we'd be lucky to see a drop of even 1 degree. Lunar eclipses would also be fascinating. Most of the time, we'd see one moon being shadowed by Earth, but occasionally, if their orbits aligned perfectly, we'd witness Earth's shadow gracefully sweeping across the surfaces of both moons, a profound reminder of our place in the vastness of space. Our twin moons would still follow a monthly cycle, transitioning from new moon to full moon, much like we're accustomed to. However, a remarkable consequence of having two moons would be that full moon nights would shine about 30% brighter. This is because the combined surface area of these two smaller spheres reflecting sunlight back to Earth is actually greater than that of our single moon. Full moon nights would be significantly more luminous, which, while beautiful, might not thrill astronomers who already find our moon's brightness a challenge for observing distant stars and galaxies. But look down at the ground, and you might notice something quite peculiar: two shadows. The separation of our twin moons would be significant enough to cast two distinct, overlapping shadows. The further apart they drift, the more separated these shadows would become. Now, I already anticipate the questions about orbital stability. You might be thinking about the three-body problem and the potential for chaotic orbits. But here's a common misconception. For systems like this, there's a concept called the Hill sphere. Think of it as a boundary that defines the region where an orbit remains stable. We experience this today with our moon orbiting Earth. While we both orbit the sun, Earth's Hill sphere is vast, and our moon's orbit is well within it, ensuring stability. If an object ventures outside this boundary, the sun's gravity can disrupt the delicate balance. For our twin moons, their Hill sphere is considerably smaller, but because we've set their orbital separation at 10,000 kilometers, they would remain nicely within the stable zone around Earth for thousands of years, never drifting far enough for Earth's gravity to pull one away. What about the tides? We know the moon and sun are the primary drivers of Earth's tides, creating bulges of water that our planet rotates through. In our two-moon scenario, you might expect tidal patterns to become erratic. Surprisingly, the tides would remain remarkably similar. You might experience a slightly higher high tide now and then, but gravitationally, the system would feel almost identical to our current one. Since the total mass of the two moons is the same as our single moon, the gravitational center of their system is indistinguishable from our current moon's influence. Now, here's where things get truly spectacular. If the initial conditions weren't perfectly precise, and the orbits of our twin moons began to decay, spiraling inward towards Earth, something extraordinary could happen. There's a region around Earth known as the Roche limit, about 12,000 kilometers above our surface. Any celestial body held together by its own gravity that crosses this limit would be torn apart by Earth's immense gravitational pull. Our baby moons would be disintegrated, and we would be left with a breathtaking spectacle: beautiful Earth rings, a pale, luminous band arching across our sky. For those near the equator, it would stretch high overhead, while those closer to the poles would see it as a delicate band on the horizon. At night, we'd be treated to a glorious view of these rings, glowing brighter than the Milky Way. While astronomers might not be thrilled, the visual would be unparalleled. Sailors could use them as a celestial compass, and our low Earth orbit satellites would need to adjust their paths to navigate around them. We'd even see ring shadows moving across the Earth's surface. And the most astonishing part, this isn't just pure fantasy. Geologists have discovered evidence of a specific type of meteorite distributed around Earth's equator, dating back about 500 million years. This suggests that a large asteroid once grazed Earth, breaking apart within our Roche limit and forming a dusty ring system. These rings then gradually fell back to Earth over millions of years, creating the deposits we see today. If our twin moons were to form such a ring system, they would persist for a similar duration. And imagine the possibilities. We could even mine these rings, extracting resources already in orbit to construct solar arrays or even space elevators. This phenomenon isn't exclusive to Earth. Mars' moon Phobos, which we mentioned earlier, is actually on a trajectory to pass within Mars' Roche limit, promising a ring system for the red planet. So, as we look up at the night sky, a new question arises. Would you prefer to have one moon or two? Thank you for joining me on this cosmic exploration. If you enjoyed this journey, please consider following for more fascinating explorations of our universe.